today's goal of this lecture. Today I will see Laurent series. In my previous video, I had discussed Taylor series. In my previous video, I had seen if f from u to c be analytic function in the domain absolute value of z minus z0 less than r, then f has a power series expansion such that fz equal to the power series expansion as like n equal to 0 to infinity an z minus z0 to z0 to the power n, where an equal to f to the power n z0 over n factorial. This is the z0. That means in this neighborhood r, in this neighborhood n r z0, the function has a power series, and in this neighborhood the function is analytic. I hope my all viewers have understood this is clearly. What is the Laurent series expansion? We all of us know this is actually the Taylor series expansion. Today I will see what is the Laurent series expansion. When the Laurent series expansion be applicable. That means when a function be analytic, and we all of us know analytic means it is differentiable in a neighborhood, and in this neighborhood always there exists a power series, and this power series is actually equivalent to Taylor series I had seen. Now I will say when Laurent series expression applicable. Sometimes f may not be analytic at some point, and when f not analytic some point, then this point is called singularity. What is the definition of singularity? Let's see at first. This definition of singularity: a point z0 at which the function f fails the analytic, this is called the singularity. And singularity is two types: one, isolated singularity, and second, non-isolated singularity. What is the isolated singularity? A singularity of the function f for which there exists a deleted neighborhood. Since here I have considered it, the point z0 is singularity, that means the function at this point be not defined, but isolated singularity means there exists a deleted neighborhood of around the point z0 in which the function is analytic. As for example, fz equal to 1 over z. We all of us know at the point z equal to 0 function is not defined. So at the point z equal to 0 has a singularity. But this singularity is isolated singularity because if we draw any neighborhood, any radius of neighborhood, always without this point the function be analytic. So z equal to 0, this is the isolated singularity. I hope my all viewers have understood what is the isolated singularity. Another singularity is non-isolated singularity, and non-isolated singularity is this: a singularity z0 of the function f for which every neighborhood of z0 contains another singularity. If we consider fz equal to log z, here capital log z, function, we all of us know, function is not defined in negative real axis. In negative real axis, the function has a singularity. So this singularity is called non-isolated singularity. Because if we consider any neighborhood here at any singularity, then always there exists another singularity also. So this is non-isolated singularity. And when function has a singularity, then we cannot define Taylor series. Then Laurent series be applicable. I hope my all viewers have understood when Laurent series be applicable. When function may not analytic at some point, then Laurent series be applicable. That means the idea of Laurent series is consider the point z0, and in this point, in this neighborhood, around this point, the function is not analytic. But if we draw this type of region, in this region the function is analytic, only not be analytic in this region. So for this case, this type of case, Laurent series be applicable. And here the Taylor series is for n equal to 0 to infinity. But Laurent series also be used for minus infinity case. That means Laurent series applicable for n equal to minus infinity to infinity. Okay, I hope my all viewers have understood when Laurent series be applicable. That means actually the Laurent's theorem is, the theorem of Laurent series is, suppose f is analytic in the analyzed domain, R1 less than modulus of z minus z0 less than capital R1, where C is positively oriented simple closed curve lying in the analyzed region, then at each point z in the domain. That means the picture would be such type. Here at the point z0, around, this is the radius R1 and this is the radius capital R1. In this region, function is not analytic, function only analytic here. Then at each point z in the domain, the Laurent series expansion such as fz equal to n equal to 0 to infinity a n z minus z0 to the power n plus n equal to 1 to infinity b n over z minus z0 to the power n. This is the Laurent series expansion. This is positive part. This is actually the Taylor series expansion. So this is called the analytic part. And this negative part is called the principal part. And since function is analytic here, so we all of us know a n equal to Cauchy integral formula, derivative of Cauchy integral formula 1 over 2 pi I fz over z minus z0 to the power n plus 1, and this is equal to actually fn z0 over n factorial, and bn equal to 1 over 2 pi I fz over z minus z0 to the power here minus n plus 1. Okay, I hope my all viewers have understood. This is the Laurent series expansion. As for example, find the Laurent series of the given function with center z equal to 1 and the function fz equal to 1 over 1 plus z square. Here the function has a singularity at the point 1 and minus 1, because here the function is 1 over 1 minus z square. So if we common minus 1, then this would be z square minus 1, and we can write z square minus 1 as z plus 1 times z minus 1, and 1 upon 1 plus z means, since we have to find here the Laurent series with center z equal to 1, here the point z equal to 1, but here the point z equal to minus 1. So write this series. We can, since here we have to find the Laurent series with the center z equal to 1, so we can write 1 upon 1 plus z as 1 upon 2 plus z minus 1, and this is actually this series, this is actually 1 over 2 1 minus, here since plus 1 minus minus z minus 1 to the power half to the power half to the power minus 1, and this is the geometric series we all of us know. This series would be such type 1 over 1 minus x. This is the geometric series, and the series is 1 plus x square, so on, and the series is convergence mod x less than 1. Here this series is similar to this. This series is similar to this series, so we can write this as, therefore fz equal to 1 upon 1 minus z square, we can write this as minus 1 times series n equal to 0 to infinity minus 1 to the power n plus minus 1 to the power n divided by, since here also 2, so this value would be 2 to the power n plus 1 times z minus 1 to the power n, and times here 1 over z minus 1, and the region of convergence of the series is z minus 1 over 2 less than 1, so this value would be greater than 0 less than z minus 1 less than 2, and here the point 1 and here the point minus 1, and at this point the function has a singularity 1 and minus 1, and in this region the function be convergent, and this is the Laurent series expansion about the points about center z equal to 1. I have told you I can define Laurent series in different region. When modulus of z minus 1 greater than 2, then we can write 1 upon 1 plus z. Since here we have to find the Laurent series with center z equal to 1, so we can write z plus 1 as 1 upon 2 plus z minus 1, and this is equal to 1 upon z minus 1 times 1 plus 2 over z minus 1 to the power minus 1, and this is actually the infinite series, and this is 1 upon z minus 1, and the series is n equal to 0 to infinity minus 2 over z minus 1 to the power n. I hope my all viewers have understood, and this is actually equal to n series n equal to 0 to infinity minus 2 to the power n over z minus 1 to the power n plus 1. So the series is convergent in the disc absolute value of z minus 1 strictly greater than 2. When absolute value of z minus 1 strictly greater than 2, in this region the series is convergent. Here I have considered such type of geometric series because I will say this series is convergent when absolute value of z minus 1 strictly greater than 2. So I have considered the series such type. Okay. Next, fz equal to 1 over z minus 1 times z minus 2. Here 3 types of Laurent's decomposition centered at 0. 1. Around the point z equal to 0 with radius 1. Here at the point 1 has a singularity. Another analysis. Center 0 with radius 2. Here at the point 2 has a singularity. Another z greater than 2. Therefore, that means the function fz has 3 Laurent series expansion at z equal to 0. One representation, the function in the punctured disk 0 less than mod z less than 1. Another in the analysis 1 less than mod z less than 2. And another is in the exterior domain 2 less than mod z less than infinity. And since the function is only analytic in the disk modulus of z less than 1 and decomposition in the punctured disk is given by 1 over z minus 1 times z minus 2. We can write this as 1 over z minus 2 minus z minus 1. Here f naught z equal to 1 over z minus 1 and consider f1 z equal to minus 1 over z minus 2. Since the function is already analytic in modulus z less than 1, then the decomposition in the punctured disk is given by f naught z equal to fz. This is the f naught z and f1 z is equal to 0. This is the f1 z. Since the function is analytic at infinity and vanishes there, then its Laurent series decomposition with respect to the exterior domain 2 modulus of z modulus of less than infinity 2 greater than modulus of z less than infinity is given by fz equal to f1 z and f naught z equal to 0. That means only non-trivial Laurent series decomposition is with respect to the analysis less than mod z less than 2. In this region, there exists only non-trivial Laurent series decomposition. I hope my all viewers have understood. Now I will see how look like the non-trivial Laurent series decomposition in this region. Or fz equal to 1 over z minus 1 times z minus 2 on the region 1 less than mod z less than 2. Here region with center 0. We can write this as 1 over z minus 2 minus 1 over z minus 1. In this region, the Laurent series would be 1 over z minus 2. We can write this as minus half times 1 over 1 minus z minus 2. And this is be the geometric series, and this geometric series is 1 plus z over 2 plus z square over 4 so on. That means this is minus half times 1 plus z over 2 z square over 4 so on. And 1 over z minus 1 we can write this as 1 over z times 1 over 1 minus 1 over z. So we can write this is also, this would be such type 1 over z plus 1 over z square plus 1 over z cube so on. Therefore, fz is written as series AKZK where z lies between 1 to 2, where AK equal to minus 1 if k less than equal to k less than 0 and AK equal to minus 1 over 2k plus 1. This is true for k greater than equal to 0. For this coefficient, these two coefficients, there exists such type of power series. I hope my all viewers have understood this is clearly. Okay? Well, I will stop here. I hope my all viewers have understood the Laurent series. Next, I will discuss different type of singularity in this Laurent series. Because singularity means there exists always Laurent series exist. I hope my all viewers have understood till now. Okay. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.